we have different types of fruits as raw data, and which we ingest. After ingesting, we have the supervisor who will train the data, go through the algorithm that will be suitable for the data to be analyzed, and it's moved forward towards processing. So but beforehand, there will be likely expectation that, okay, what one will be expecting from the data. That in place is more like having to know what you're looking for in order to be able to draw conclusion from. Because sometimes data can be meaningless when we don't know what we want to derive from it. So knowing our expectation beforehand gives us what we're likely to expect. So having this fruit in hand as the basics of example in order to be able to draw the sense behind what supervised learning is. We know that apple, orange, and the rest, they are all fruits, categories of fruits. So ingesting it will help us to identify, having to have a collection of fruits, we know that our expectation would be to identify the different kinds of fruits as the output. Then we will be able to know the particular algorithm to use. So in the meantime, this is basically the pictorial view, a simple understanding of what supervised learning is. Because so supervised learning is orderly, it's not scattered, and there's a structure in place on how to go about doing it. So that is why it's called supervised. You're actually following through a set of what's the word again? A set of approach to reach to a desired outcome. So how does supervised learning works? It works basically to teach models to yield desired output, like I made mention earlier. And there are various different kinds of supervised learning types. And they are all categorized into two, which we have as classification and regression. So, and in other words, for us to determine what category each of them belongs to, in going forward towards understanding how to be able to work with supervised learning, how it works basically, for us to understand how it does. So what we do is that we go through the aspect of knowing the category which belongs to classification, the algorithm that belongs to classification types. And we can see by description, it uses an algorithm to accurately assign test data into specific categories. It recognizes specific entities with the data set and attempts to draw some conclusion on how those entities should be labeled or defined. Exactly. So it is labeling the data to understand what entity it belongs to and classify them according to their characteristics. So this is like a similar thing to clustering, but it's different. So classification is about labeling. What clustering is getting unlabeled data, categorizing them according to their similar characteristics that they share. That is about the difference, but they have some similar descriptive understanding about how they work. So, and there are some common classification algorithms that fall under some common classification algorithms that are as follows, which are the linear classifiers, the support vector machines, the decision trees, the KNN, which is the nearest neighbor, and random forest. So random forest is more like an extension of the decision tree. Then for regression type of supervised learning, this has to do with the relationship of the data, how the data, the nature of the data is, to understand the linearity and the relationship that is shared within the data that is in place, basically. So in order to understand it better, it's the relationship between the dependent and independent variables. So when we say dependent and independent variables, we'll be talking about an approach whereby the data Like, let's take for instance, price of fuel. Price of fuel might be determined by the economic factors of the country. So fuel now is dependent on the economic factor of the country. So the economic factor of the country is the dependent variable. I mean, the economic factor of the country is the independent variables. But why the dependent variable is the fuel, which is the commodity in place that is being determined by the economic factor in place. So it's about the relationship between response variable, and the response variable can also be regarded as independent variables because they are the ones that give what the outcome is to the dependent variable. Then thereafter, we have the different forms of regression, the linear regression, which is the most basic form of regression, and the logistical regression, polynomial, are the most popular regression algorithms that we have in place. Then also, we have the examples on what supervised learning is. And the different examples that we have, that is the application, the place where supervised learning can be applied to, the application and its use. Image and objects recognition. Most often, we get to understand that data. Before now, I think we've done a track. We've had a section where the different data types were discussed, where we talk about structured data and unstructured data. So for that in place, image and object recognition falls within the unstructured data type. Now, but it also can be done with supervised learning can actually be applied to different forms of data types. So now we have that example amongst which are this, as you can see, image and object recognition. Supervised learning algorithm can be applied to it in order to be able to locate, isolate, and categorize objects out of videos or images, making them useful when applied to various computer vision techniques and imagery analysis. So there are various places where this has been applied to, where you have people signing in through facial recognition into places where there are high sensitive security infrastructure in place, so as to avoid impersonation when coming into a sensitive environment. We can talk about hotels, we can talk about conferences where that are strictly based on invitation, some places that are high sensitive environments. So this can be applied in such places to avoid security breach. So for the sake of people that are impersonating and the likes of it. So that is about like a brief example of where image and object recognition can be applied as a part of machine learning example. Then we have the predictive analytics. So please, you can quote me when you have questions or you need clarifications or you want, or you can, comments whatsoever that you may have. I'll be obliged to pause to hear you out. So the other one, the second example is the predictive analytics. And we all know that this is widely applied in the data science world. And most often than not, we all use this possibly in our companies where we get to analyze data in order to determine the predictive outcome thereafter. Somehow, maybe like say, for instance, we can have a situation where the sales departments want to predict quarterly sales targets to be achieved for a certain period of time. So it's a wide applied use case in various industries that cut across different walks of life. And in the light of it, it's very, very useful. It's one part of supervised learning that is very important in the application of the different areas where it can be applied to. So it provides deep insights into various business data points, which allows enterprises to anticipate certain results based on the given output variable, which helps business leaders justify their decision and as well pivots for the benefit of the organization. Like I did mention earlier, sales departments, that is the lifeblood of any organization. You have to sell to be in business. If not, business is not business. So more examples, we have customer sentiment analysis. This is where we have the likes of natural language processing as a technique in order to be able to determine this. So it is a form of supervised learning that can help extract and classify important pieces of information from a large volume of data. It depends on the context and emotion and intent, which gives little human intervention. So now this customer sentiment analysis helps to get views from customer reviews or feedbacks upon products and services that have been rendered to them. So it's a part of supervised learning that also gives very, very beneficial outcome at the end of the day for the organization, for whichever organization it is that has applied it, to bring about return on investments and revenue increase. Because without understanding what your customer wants or likes or what your customers expect, you will not be able to speak to their language. And in order to be able to get your product running, you have to understand what customers are looking out for or what they desire. So those are very important to put into place and to factor in understanding what customers will want to get. So sentiment analysis comes in play to help provide organization the insights on customer preferences on product or services as they render them. Then we have spam detection. For the spam detection, this has to do with the likes of fish mails that might be sent to some sensitive departments in an organization. There have been cases of cyber security threats where probably the finance department, that's where the money is, or that's where the money is kept, the finance department, where they get phishing mails directed by whoever the scammer is that want to impersonate the managing director in order to move funds from one account to the other. So to help that spam detection, it's a form of supervised learning that is used to classify algorithms. Organization can use that to train their database to recognize patterns or anomalies in view of the data to organize spam and non-spam related correspondence effectively. Like I did mention, so fish mails, those are the threats that comes to some organizations. So in order to be able to curb that, as a part of supervised learning that can be used to do it is the spam detection approach. So I don't know if you have any question for so far before I go further, or any comments, anything whatsoever. Are we good that I'll move forward?
Yes, sir. Good, sir.
Okay. So now we are into unsupervised learning. So for the unsupervised learning, we know that earlier I did describe what supervised learning was, because it's still the same concept of using fruits, because these are what we know, and these are our everyday things that we come in contact with to bring home the point. So for unsupervised learning, it's like I said earlier, that it's a categorization of things that share similar characteristics. As you can see from this pictorial view, we have the likes of strawberry, grapes, and the red. Or that I'm talking about the cluster one. This falls within the fruit that helps to cure cancer. Let's take for instance, because yes, strawberry and grapes helps to be able to curb cancer-related effects as a natural remedies to helping reduce the intensity of cancer formation within the breast, basically breast cancer. Yes. So that is more like the similar characteristics that they share in place, as why they are categorized to a cluster. So the likes of the orange, the apple, that is for the cluster 2 right now, and pears and the likes. So what they do, their function basically helps to depict the benefits one derive from it. Like I did describe for the cluster 1, that it helps to reduce the effect of cancer, because that is the similar characteristics that they share between themselves. But they are all fruits, both cluster 1, cluster 2, cluster 3, they are all from the same category of fruits. Now, initially for the supervised learning, they were all fruits, yes, but the outcome helps us to understand the individual sets of fruits. That was the outcome for the supervised learning. But for this particular case, for the unsupervised learning, we are talking about the characteristics that the group of fruits share as the outcome of the analysis. Because now we have the basket. You can see the woman standing by the side. We have the basket of all of the fruits together. So when this is ingested into the data, into the pipeline, and it's being trained, and after which the outcome, the output will now be demarcate them into different clusters as they share the different as they share the similar characteristics together, in order to be able to factor them into their different clusters. And that also goes for cluster 3. So that is about the brief description of what unsupervised learning is. So let's go more into how best it works. So for unsupervised learning, it is a machine learning algorithm that helps analyze and cluster unlabeled data sets. Now, this is a difference. Unlabeled, they are not labeled. But for the likes of the supervised learning, you get to have labeled data according to what they are. So this, you just have a bunch full of for instance, for this, let's use this particular example that's within the context of what we know. Like when we are talking about selection pool in places of lottery, they're labeled actually. They are labeled. So that example will not really play out here. Let's leave that aside. I will still bring about the other examples that we can use, practical examples in place. But for the sake of this, let's move ahead. I will think about that later. Now, so this algorithm detects, it helps to discover hidden patterns in the data without the need of human intervention. Hence, they are unsupervised, exactly. So without the need of the human intervention, this is actually the main difference between the supervised and unsupervised learning. So there is no need for the intervention of the human to be able to dictate and determine the different characteristics for which they belong to. It's after the data has been trained and the algorithm is selected, you leave the machine to do the rest. The unsupervised learning models are used for 3 main tasks, basically: clustering, association, and dimensionality reduction. And for clustering, that is the most known unsupervised learning in the data science world. And it is a technique for grouping unlabeled data based on their similarities or differences, like I did describe earlier. So for example, we have the k-means clustering algorithm, which helps to assign similar data points into groups, where the k value represents the size of the grouping and granularity. This technique is helpful for market segmentation and image compression and so forth. So market segmentation, exactly. So we have, there's this technique that we know as RFM, recency, frequency, and monetary. So for market segmentation, basically, like where clustering can be really applied to, for the recency, frequency, and monetary, the RFM analysis helps to segment customers into their different characteristics. Now, their characteristics can cut across high spenders, frequent buyers, and once in blue moon top buyers. So, within our organization, we know those who are the frequent buyers, our normal regular customers. I will also know those who are the high spenders. They come at some certain season to buy products based on demand. So, and when they're coming to buy, they buy at high end. And we have those who are one-time investors. They just come, buy, and that is it. So those are like the scenario where clustering can actually take place. And in that light, the technique can be used for market segmentation. And we'll talk about image compression. Image compression can help us to determine some images that are blur that will need to clarify the particular point where these images ought to fit into. So that is just me explaining it by words, and the practical aspect of all of this will come into place in our subsequent series. Like I did mention earlier, that this is just a theoretical introductory section for machine learning types, for common machine learning types, for the track that we're in right now. So I crave our indulgence to align with me on what I'm describing, and for the practical aspect that is not in place, we'll still deal with that later. And the second form of unsupervised learning is the association. So for the association, it's another type of unsupervised learning that helps to find the relationship between variables in a given data set. So this is likened to be similar to regression, but it's different. Now, where does the difference take place? We know that, let's use an example to determine that for market basket analysis and recommendation engines, we have along the lines of customer who bought the item also bought recommendations. Now, association, the difference between association and regression, because they are both talking about relationships. The association deals with the facts whereby, let's say, for instance, you are selling, and the product you are selling has an accessories to add up to it. With the likes of trying to get an example of my head, so it really speaks more of upselling when you're selling a product. We can talk about maybe when we go to supermarkets, we can see a basket of provisions. Where maybe you buy something like bread, and the next thing that will be asked is, wouldn't you need something like Milo or milk to add up to it? Because of course, bread is used to take tea, and all of those. So, bringing those things together would be recommended that, okay, take this alongside with this. This will fit in for this because you are upselling. So those products are associated to each other. That is the essence of it, basically. Then you talk about Netflix. So in Netflix, you have movie genres like the action, the comedy, the fantasy, the comic, and the adventure. So all those movie genres and types, the one is most frequent to watch according to your account, there's an algorithm that will take place within the Netflix environment to recommend those movie types according to your watch history to you to watch as part of the kind of genre that you like to see. So, it's the practical aspect of what association means. So now, if you're taking it to differentiate between association and regression, you see that association has to do with like upselling in the business case scenario. Then for regression, we're talking about understanding the relationship that exists between the response variable and the independent variable. It's that the response variable gets its outcome from the independent variable, from whatever it is that is put in place. So comparing it to association, you see that there's a thin line difference between it. Well, association is for upselling. Let's just say regression is for determining the relationship between the response and the outcome. The response is the outcome, basically. The response and the independent variables to determine that. So the third one is the dimensionality reduction. So this helps us to avoid bias and then to reduce errors when we are training data. So what it does basically is a number of features in a given data set. If it's too high, it helps to reduce the number of data inputs to a manageable size while also preserving the data integrity. Like I did mention, that it helps to reduce bias because when training data and it gets overboard, that's the error becomes high. When the error becomes high, there's a problem. It's either the data has too many features or the data has less accommodating figures to put in place. Because one, you have to make sure that the data is not biased and the variance is also normal. So dimensionality reduction helps us to be able to avoid this in order to help us to reduce the number of data inputs to a manageable size. At the end of the day, it is what we analyze and we do that will determine what the outcome will be based on what we put into place. So this is a technique that is used in pre-processing data stage, such as when autoencoders remove noise from visual data to improve picture quality. It still speaks about that instance of bias, to reduce bias, basically. That is what it actually does. Okay, that is for unsupervised learning. I don't know at this point if we have any question or comments or suggestion whatsoever before I move to the third one, which is the reinforcement learning.
I have an observation, a question, if you can. Now, when you talked about, if you go back to the slide, the dimensional learning, dimensional reduction. Now, I know there was time that we had issue when you create a model that speak to gaining pictures of people and trying to use this for probably for 1060, especially to know who the person is. There have been issues that African face because of the pixel and because of the I don't know what happened then. They hardly recognize a black face. Maybe the model that was created in the past, if you look at the evolution of AI, was basically for a white face. I don't know whether this is what is being used to reduce that and to help to enable people that build model to have a better classification of people irrespective of their race, their color, or their gender.
Okay, so if I understand you correctly, sir, you're asking if the dimensionality reduction is used to determine, based on picture quality, the different race to which they belong to, if I'm right?
Yeah, because in the past, why I say in the past, I read something in the past that, when you go into before a camera now, and the camera is running on maybe a machine learning model, and that camera take your picture. Sometimes it's very difficult to recognize if that person is black, and it is like they just have a common pipeline data set for all blacks, as if we are all the same. So I don't know whether this dimensional reduction under unsupervised learning is used to help to reduce that occurrence that was happening in the past. And if it's not, is there a way, has that issue been solved with the new machine learning studio and all those algorithms that have been popped out by Microsoft or any other organization?
Okay, thank you very much, sir. So to answer that, dimensionality reduction doesn't play into that role because
Okay.
there is already a technique for image detection. So, and that was what I described earlier in the supervised learning. So we have this image and object recognition. It falls under the supervised learning. So there are different techniques that can be adopted to this to determine the color or race. So it actually depends on the data that is in place. It actually depends on the data that is in place. Because when training those data and the algorithm that has been used is running, over time, it picks similarities, it picks content that are looking the same to each other, whereby while the analysis is running, there will always be errors to mitigate against. Now, because you can't have 100% accuracy when running your data analysis and training data as well. That is why you apply some that is why we apply some techniques in order to reduce errors. Now, dimensionality reduction comes into that, it plays into that role of reducing data that is overboard, that is, overboard, bringing it into a manageable size. In the sense of that fact is that while the data is streamed, because right now I actually would have like to describe, to do it in a practical way. We could just train a data, see what possible outcome it could create to when the data is actually overboard, and we're trying to classify and differentiate them according to to whatever it is that our expectation is at the end of the day, what we need, what we want to get as an outcome. So for now, the scope of what we are trying to describe here is that dimensionality reduction helps us to reduce bias. So for the image description that you observed, the image recognition technique is what is used to determine that, basically. So, but I will still look more into what you've said. I've taken note of it to maybe when we have our next section, I'll have a better answer to it.
Okay, so dimensionality reduction is typically run, because we are running an unsupervised algorithm. That means all those data are not really labeled. So you need to be able to reduce bias to the bias limit. So that's why you use dimensional reduction. Now I'm
Yeah.
just trying to play it into the image capturing and image play out in terms of trying to use a model that can help you to detect whether this is a black man, a white man, what is the color of his eyes, and the rest, and to be distinct in deciding what that kind of person is. So maybe I'll wait for the next section to see how it plays out. Thank you.
All right. Thank you, sir. Is there any other question, observation, or comment before I move on from anyone? So can I proceed?
Yes, I think if there is a question, people raise up their hand. There is no question from here.
Okay, thank you very much. All right, so this is the third machine learning type. Like I said beforehand, there is semi-supervised learning, so it's not included in this scope. So the reason is that it really hasn't, it doesn't really have much context to be able to describe it, except for the fact that it's a mixture of the supervised learning and unsupervised together. So you having a labeled data and having unlabeled data to bring it together to analyze and the likes of it. So in the practical aspect, we'll see how that plays out. But for now, we are describing the main forms of machine learning types, which we've talked about the first two, the supervised and unsupervised. Now we are on this, which is the reinforcement learning. So reinforcement learning is a machine learning type that is used for high-end data analytics. We talk about the deep learning. So it's an algorithm that gets to choose an action in response to each data point. Its common approach is in robotics, where the set of sensors reading at one point in time is data point, and the algorithm must choose the robot's next action. So in the progress of my explanation, we'll get to see a picture overview of what reinforcement learning does, a descriptive pictorial view though. So it's also a natural fit for Internet of Things application. The learning algorithm also receives a reward signal a short time later, indicating how good the decision is, or was, basically. So based on signal, the algorithm will give what the outputs will look like. So this is a pictorial view, like a concept of what reinforcement learning is. So we get so it's more like you learning from mistakes. So let me go back to the first instance of my presentation where I talked about the different types. You can see what reinforcement learning is. So we learn from mistakes. So now, basically what reinforcement learning is, learning from mistakes. So the likes of Tesla, the likes of SpaceX, we know what Elon Musk has done over time in trying to launch spaceship in the space, or the multiple failures he has had in doing that. So it is the deep core of what reinforcement learning application is in spaceships. So over time you ingest the raw data across board, how spaceships are being constructed in order to fit into the space when it's launched. So the Elon Musk company and the likes of the SpaceX and Tesla, the Tesla is just basically for cars, those, but the SpaceX is for the spaceships. So now we know that it has had a couple of failures over time, and doing the job of trying to understand how to succeed with what he has done. He was learning from his mistakes. He was putting in the reinforcement of making more observation, getting to understand what went wrong initially so as to correct it further and still try out the launch over time so as to know how best to be able to get it successful. So eventually, I think about up to 4 trials before he was able to succeed in launching a spaceship into the space. So the reinforcement learning, that is the practical approach of what it does. It's that is where it can be applied most often in the robotics. It's in the robotic area, AI. Let me put it that way, artificial intelligence. So yeah, we can see from this pictorial view how we input raw data, that will bring it into the environment, and the environment gives like a pre-informed reward for us to know what it's likely to be once it's successful. Then we have an agent. An agent is not the robotic. The robotic now plays out in trying to engineer a set of algorithm to select which is going to play out right. And after it has been gone through that selection part, we now determine the best action to be able to be successful in the environment. Now, like I made mention of spaceships and space. Now we know that the spaceships is the agent. That is the pilot. Well, sorry, not the pilot. The one who's taking, I don't know the name. I have to determine that later. The one who drives what's it drive? Well, however, I think I'm trying to say whoever that controls the spaceship into the space is the agent. Then the environment is the space itself. So now, like going through the reward aspect is okay, successfully landing to the moon, successfully seeing the stars, the galaxy of stars, the constellation of earthly planets in the space, all of those. So those are like the rewards to have in mind. Then the state, like I explained, you will now be the robot determining what it is that he has right now and what you should be able to find out for into the selection of algorithm, then determining the best action that will help to be successful in the space, which is the environment. Now, the output is what we have, getting to have the picture overview of what space looks like and analyzing the success rates from taking off to arriving, the time factor, and at what time it was that it was successful. So all of those are the outputs. So that's about like a descriptive overview of what reinforcement learning is. Going further, like I made mention, these are the real life application in self-driving cars, like the likes of Tesla and other companies that are coming up also in this space of self-driving cars. So we have others. So it can be applied in natural language processing. We talk about mistakes, learning from mistakes. So we know that in chatbots, reinforcement learning also helps in that. Where you have chats that, I mean, when you have a chatbot, for it to be more intelligent enough, you have to go through series of test running responses. Maybe when it is a conversational chat that you want to have with the chatbot. Some chatbots are static, that are not intelligent enough to be able to understand the natural human language. So in order to be able to help the chatbot to be more intelligent enough, so those mistakes that you get to see while you try to have a chat with the chatbot, if Lewis was integrated into it, it would pick it up to make it conversational. So now, let me not go outside of the scope of what I'm trying to describe. So Lewis is just more of the conversational cognitive service of Microsoft for chatbots. So what I'm trying to explain is the reinforcement learning application in natural language processing. Now, using the chatbot as a case scenario, it has to do with you conversing with the internet to determine what you need to get at the end of the day, the response basically for support purposes. So all of those mistakes will be captured, and at most of the time afterwards, after it has been captured, it will be analyzed and categorized and reinforced to provide better answers when that same questions are asked. So I believe that was explanatory enough. However, I try to make sure that I bring it down to understanding what I'm trying to explain. So other real life applications, as you can see, we have it in robotic application manipulations, like I mentioned earlier. We have it in marketing and advertisements in the business world for real-time bidding. So we know that in the marketing industry, you sometimes market some product that don't sell. So we tend to learn from what we've done previously that was not successful, that we have to work on in order to be able to market and advertise well and for the product to move. So reinforcement learning can be applied to that. And so we have reinforcement learning application in trading and finance. So for investment purposes. So this has to do with like the likes of stock prices and stock investments and other finance and other financial industry investment portfolio or platform to apply to using the reinforcement learning. So that is just about understanding what reinforcement learning is. So to wrap up, excuse me. To wrap up, I have this machine learning algorithm cheat sheet. I will share a link in the chat section for us to be able to download this cheat sheet. So it's very helpful. Why? Because it helps us to understand at what point in time we are to use a set of algorithm in analyzing and training our data, understanding how to apply it. Because sometimes we have data, we train it, we don't know the particular algorithm to use because we've not determined what we want to do. You know, like I did mention earlier, for you to be able to get your data analyzed properly, you have to know the outcome. You have to see the end before you start. Seeing the end from the beginning, knowing what to expect from the data will help to guide us in knowing what to do along the line and what algorithm to choose to be able to do that. So this cheat sheet will give like a heads up to know what algorithm we should use or apply to help us to sort our analytic jobs and the models that we train, the outcome thereafter. So we can see we have the text analytics, derives high quality information from text. It answers questions like what info is in this text. Then we have the regression. The regression has to do with the forecast by estimating the relationship between values. And now it answers questions like how much or how many. So if you are looking out for some answers in your data, maybe it's about determining how much forecast is going to be in the last quarter of the year. That is from the sales scenario or standpoint. You know that you are looking at using regression to be able to determine that. Then we have the multi-class classification. It answers the questions like, is this A category or B category or C category or D category? So underneath it, we see that there are different methods and techniques that you can use to do this, to use these algorithms for. Then down we have the two-class classification, we have the image classification, answering the questions like, what does this image represent? We see the different techniques that can be applied to be able to determine that. Likewise, the anomaly detection. The anomaly detection is for the spam. It's for the spam detection that I explained earlier. So you see, clustering and recommenders. So you can see what questions it helps us to answer what would they be interested in. So this is a cheat sheet that's going to be very helpful for us in determining the machine learning algorithm type to use. So rounding up this section, we've talked about the supervised learning, the unsupervised, and the reinforcement learning. And so far, this is where we close the curtain for the day. If there's any question or any comments, observation that needs to be outlined at this point, I'm done with this section. Thank you very much for listening.
Okay, thank you, Ezekiel, for that section. Before Paul comes up to give us a final close for the day, I also like to inform you that next week we are continuing with the track. Is a track that will extend to December. But just we keep you posted if there's going to be a rescheduling, especially if there's an activity that's going to happen that not make us to have the event. Then we can actually move, because we're having a boot camp coming up 26 to 28. If you have not registered, please, Paul will just put the link for registration there, or I can get it and just put it down there. Please kindly register. It's going to be, and if you register now, you are entitled to get some free gifts. One is you get training for fundamental on Azure, on Power BI, on Azure IoT, free for 2 days, free of charge. So if you have not, please, I'll put the link here now. Try to go and register and get yourself set for that program. That's the only time, or if there's any other time, that will let you know that we might not have the training. But next week, we're going to continue. We're bringing another speaker who is going to talk about the core machine learning concept. What Ezekiel was able to let us see is what are the common machine learning types, which is the supervised, unsupervised, and the reinforcement. Now, let me just summarize it in my own knowledge. One, supervised is the one that is labeled. You have structured data that is categorized and tagged. Then unsupervised is a learning that you do for data that are not labeled, that are random. You just bring them into a particular cluster and you create an algorithm to be able to sort it out. And with that sorting out, you can get result and output from there. Then the third type is the reinforcement, which I don't know whether Ezekiel will agree with me, but in my own summary, that means is trial and error. You have all your data, and as you create, I don't know how far that trial and error is in the percentage of likelihood, but what it means is that you have data, that you have created a model that you have created, and as you launch this model, you start learning. And that's typical of where you have created a chatbot if you have created a chatbot, there is what we call Louis. Louis is Microsoft own Microsoft own uh, cognitive service offering model that you can go online as you are creating that your chatbot, like when you have Ada, Leo from UBA, all those chatbots that you speak with, you now begin to learn from it. So most time, this is how this is created and is reinforced with time. So next week, I want all you guys to not to forget to join by 12 noon, and that we're looking at the core machine learning concept that is going to be taken by Benga. So please put that in mind. And finally, I want to place the link for the boot camp that you can get something from, especially for you to have your gifts. And if you are part of the boot camp for 3 days, you can win. There's a raffle draw that is going to take place that you can win an Xbox. The Xbox will be shipped to you maybe a month or 2 months after the event. But meanwhile, that is the link to register and take part in this, and you'll be able to win all this. I've sent that link to you, Paul.
Okay, thank you very much for that introduction, for that conclusion. I wish every one of us to links as he has indicated. I've also dropped some of the links to our social media platforms and to engage with us. So we appreciate you, Ezekiel, for the fantastic presentation. As for me, I've learned a lot, and I think I would want to
leverage on these ML algorithm cheat sheets, subsequently. I believe it's same also for other participants. And so same time next week, Saturday, 12 noon, we'll be having the session. So if you also have missed out on some of the sessions, we have them recorded and uploaded on YouTube. The YouTube link is already uploaded and in the chat. So you can click on the link to, view subsequent sessions. Thank you everyone for attending today's session, and see you next week. Thank you.